Hello dear students, welcome to a new episode. In this episode, we'll be talking about the axis of symmetry. First, we're going to learn about the axis of symmetry of the isosceles triangle. The isosceles triangle has one axis of symmetry. It is the straight line drawn from the vertex angle perpendicular to its base. Like here in this example, it is AD. Let's note that the equilateral triangle has three axes of symmetry. They are the three perpendiculars drawn from its vertices to the opposite sides. The scalene triangle has no axes of symmetry. So, dear students, the scalene triangle has no axes of symmetry. The isosceles triangle has only one axis of symmetry, where the equilateral triangle has three axes of symmetry. Second, we're going to learn about the axis of symmetry of the line segment. The straight line perpendicular to a line segment at its middle is called the axis of symmetry for that line segment. In brief, it's known as the axis of a line segment. In the opposite figure, if the straight line L is perpendicular to AB and C belongs to the straight line L, where C is the midpoint of AB, then the straight line L is called the axis of AB. Let's read this property together. Any point on the axis of symmetry of a line segment is at equal distance from its terminals, or which is called the endpoints. Let's read another property. Any point on the axis of symmetry of a line segment is at equal distances from its terminals. Let's check this property together. Any point on the axis of symmetry of a line segment is at equal distances from its terminals. The terminals are the endpoints. In the opposite figure, if the straight line L is the axis of AB, where D belongs to L, E belongs to L, and F belongs to L, then DA is equal to DB, and EA is equal to EB, and FA is also equal to FB. The converse of the previous property is also true. If a point is at equal distances from the two terminals of a line segment, then this point lies on the axis of this line segment. As shown in the opposite figure, if C is a point such that CA is equal to CB, then the point C lies on the axis of AB. Exercise 1 says, complete each of the following. Number 1, the straight line drawn from the vertex of the isosceles triangle perpendicular to the base is called what? Yes, excellent. It's called the axis of symmetry of it. So here in number 1, it's called the axis of symmetry of it. Question 2. The number of axes of symmetry in the equilateral triangle equals, yes, excellent, equals 3. The number of axes of symmetry in the isosceles triangle is equal, excellent, it's equal to 1. The number of axes of symmetry in the scalene triangle equals, excellent students, 0. Question 5. The axis of the line segment is what? Yes, it is the straight line perpendicular to it from its middle. Question 6. Any point belonging to the axis of a line segment is, yes, excellent, is at equal distance from its two terminals. Question 7. If C belongs to the axis of symmetry of AB, then CA is equal to CB. Exercise number 2. Choose the correct answer. The axis of symmetry of a line segment is the straight line which is, excellent, it is the perpendicular bisector. Question 2. If A belongs to the axis of symmetry of BC, then AB is congruent to AC. If A lies on the axis of symmetry of XY, then AX is equal to AY. Question 4. If triangle ABC has one axis of symmetry and the measure angle of ABC is equal to 140 degrees, then the measure angle A is 20 degrees. Question 5. The triangle which has three axes of symmetry is the equilateral triangle. Question 6. The quadrilateral ABCD, in which BD is an axis of symmetry of AC, may be a rhombus. Exercise 3. In the opposite figure, XL is equal to XY, where ZL is equal to ZY, and M is a midpoint of LY. How can we prove that? X and Z are on the same straight line. So we're going to write, since ZL is equal to ZY, therefore Z belongs to the axis of symmetry of LY. And also, since LX is equal to YX, therefore X belongs to the axis of symmetry of LY. Therefore, XZ is an axis of symmetry of XY. Since M is the midpoint of LY as given, therefore M belongs to the axis of symmetry of LY. So that proves that points X, M, and Z are on the same straight line. And now, let's move on to the evaluation part. Please, dear students, pause the video, try to answer the question yourself. After that, play the video again to check your answer. Let's answer the evaluation part together. In the figure opposite, AB is equal to AC, where BC is 10 centimeters long, and the measure of angle BAD is 30 degrees, where AD is perpendicular to BC. The first requirement is to find the length of BD and AD. First, since AB is equal to AC, then triangle ABC is isosceles. Since AD is perpendicular to BC, therefore AD is the axis of symmetry of triangle ABC. Therefore, AD bisects BC, angle CAB. Therefore, the measure of angle CAB is 2 times 30 degrees, which is equal to 60. So that means that triangle ABC is equilateral. So BD is half the BC, which is half the 10, which is 5 centimeters, where AD is, we get it by Pythagoras, is 10 squared minus 5 squared, which is 5 square root of 3. The second part of the question, where they're asking you how many axes of symmetry are there in triangle ABC. As we mentioned, that triangle ABC is equilateral, so it has 3 axes of symmetry. For the third part of the question wants you to find the area of triangle ABC. So area equals half times base, which is BC, times height, which is AD. So it's half times 10 times 5 square root of 3, which is 25 square root of 3 centimeters squared. By solving this problem, we came to the end of our session. Thank you very much and good luck.